Alright, you guys, so let's start our new little journey. Let me fix my camera there. New week, new ideas. Very visual in nature this week for a lot of things that we're going to do. So whereas last week we laid a lot of algebra groundwork, solving equations, using our golden rule, this week we're going to get a little bit visual, but as you'll soon find out, we're still solving equations. So let's get to it. Please make sure you understand the algebra basics. As you will see in the near future, it's the algebra, the meanings, the definitions that I'm going to be giving you that are really more important. We actually build new math ideas with them as opposed to the technology. The technology is just a really quick way to observe what we're expecting to see. And it's great and it's good, but it just gives what I call instant gratification and some answers. But to really understand the technology or to use it better, you actually have to know the algebra behind it so you can understand what you're looking at and even help the calculator along, as you'll see in a future graphing calculator module I put together. Because if you don't know your algebra, your graphing calculator is useless. So more on that later, but let's get to the math. The first thing that we want to do to start this week and pretty much the rest of the semester is let's make sure we really truly understand what a graph is, right? I think we know that a graph probably looks something like something of that nature, right? So there's basically a graph, right? Or perhaps in past classes, maybe you've seen things with what we call a bar graph, right? Or maybe you've even seen some graphs where it's just a scatter plot, something of that nature. So all of these are basically graphs, right? And essentially there's two ways we can look at what a graph is. The first way is to think of it as a visual representation of data, right? And so we go out and we collect data. Maybe I'm doing some market research, and I find at a certain time of the day, right, we have a certain number of customers, right? And so I basically pair off that data, right? At 7 a.m. there was nobody. At 8 a.m. there was 10 people, et cetera, et cetera. I build some data, right, and then I go graph it. So perhaps I create a scatter plot of that data, right? Or maybe I make it a bar graph, or maybe I start seeing a pattern and I put together kind of a continuous graph. So what we use graphs for, one of the definitions is it's a visual representation of data, right? But getting a little deeper, you'll notice that in math, we're always dealing with an equation, like y equals x or y equals x squared, like I have here, right? And so the data that we obtain from these equations, right, actually turn out to be what are famously known as solution points. All right, so I'm going to come back to our definition of graph. I think this pretty much takes care of it. But after I talk about what a solution point is, we're going to go back and redefine what a graph actually is. So what a solution point basically is, this is an ordered pair. Let's call it x comma y, that makes the equation true. In essence, it's a solution. Go back to last week. That's what I told you a solution is. It's a value we find for the variable that when I plug it in, makes a situation true. Well, we have the same thing here. So our solution point then, right, is basically an ordered pair that when I plug it into the equation, it actually makes the equation true. All right, and so what that basically comes back to here then, what is a graph? It's a visual representation of solution points. And so what that also means, this is where it gets really deep, this graph that I have here, there's some equation out there that all the ordered pairs along it, right, any x, y that I choose on that data, on this graph, right, will solve some equation. For those who've probably seen this, right, there's some x cubed graph that basically fits that function. You guys are probably used to fitting lines and parabolas, but it still goes, there's some equation. You guys know that as y equals mx plus b. And parabolas, right, there's some y equals ax squared plus bx plus c. There's some equation that is the backbone behind the picture that we're seeing. Because the solutions to that, the ordered pairs that solve that equation, basically create the graph, or what I call the pattern. So a graph then is a visual representation of solution points. And so now the question is how do we find those solution points? Because if I can find the solution points, then I can start creating a table of data, if you would, and that therefore gives me the pattern I have, and then I can basically look at my graph. See, I can basically see all the solution points. There's actually an infinite number of them. So hopefully this is making sense. A lot of math built on that. So again, without a calculator, how do we graph? Well, if you're following my story, we have to find solution points. That is the key, right? Usually 3 is enough. Don't be surprised if you do 4 or 5, especially if we're doing this by hand. Which again, I understand that kind of stinks, and the graphing calculator just does everything we're going to do so much faster. I get that, but the understanding of what we're actually looking at is important. Every picture you see has some equation behind it. So how do we generate solution points? Well, sometimes the graph's so easy I can just see it, right? So in this equation, whatever my y value is equal to x. So if I'm thinking of ordered pairs, I'm thinking of things like 2 and 2, right? In that case, x is 2 and y is 2. So clearly, when I plug it in the equation, it makes it true. Solution point, right? 3 3's on the graph. Okay, so we know, again, if I let y be 3 and x be 3, I get a true statement, so that's also a solution on the graph. If you're struggling, when things get a little more difficult, what we start actually doing is building a table, right? And the cool thing about it is you can usually let x or y be whatever you want, but we typically let x equal a number, especially when we're going to eventually turn into functions. So take out your favorite number, all right? So maybe your favorite number is 7. Plug it into the equation, right? So y equals 7. And you magically have your solution point, 7, 7, right? Maybe you like to be negative, right? Math stinks. So go ahead and let x equal -2. And of course, if I come to my equation, I plug it in, we find that y is -2. So at this point, what I've done is I've got 1, 2, 3, 4. I have 4 solution points to the equation y equals x. Are there more? Yes, right? There's actually an infinite number of them. But rather than graphing them all, right, let's go ahead and graph what I have, and maybe we can start to see a pattern. We can actually visualize where all the rest of them, right? We can actually visualize all the other solution points in the data. So what I have is 2, 2 on the graph. I've got 3, 3 on the graph, right? I've got -2, -2 on the graph. And with those 3 data points, you can already see what's coming, and we have 7, 7 on the graph. So it is pretty clear where are all the other solution points. They're basically falling along this line. These arrows are important. They're telling that this goes on forever, right? This is not just a line segment from one point to the other point. So don't forget your arrows. So again, the idea, and you can even see, right, there's 0, 0 on the graph, clearly that satisfies it. Here's -1, -1 on the graph, clearly that satisfies it. So any data point, this is a visualization of all the solution points, all the ordered pairs that solve that equation. So what happens if we change the equation? Well, if we change the equation, we're obviously going to change the pattern, and we're going to change the graph, right? And so again, you can either do it by inspection, or how about we prepare for what's coming in the future, right? Just start point plotting. That's basically what this is called. All right, we're just going to start point plotting. So again, choose some favorite numbers. I think it's actually really good to try a couple negatives, try 0, and try a couple positives. That pretty much will give you a lot of information. The more data points you have, the better the pattern will look. And so if I plug in a -2 into the equation, we find that y is 4. So I've just found a solution point. That ordered pair solves that equation, right? When I let x equal -1, plug it in, I get y equals 1. So I just found another solution point. If I let x equal to 0, we get that y equals 0. So I just found another one. Let it equal 1, right? We get y equals 1. Let it equal 2, and we get that y equals 4. So I just found another one. So right now I've been able to generate, via point plotting and plugging things in, right, I've generated 5 solution points, an ordered pair that makes this situation true. Are there more? Heck yeah, there's a lot more. But let's go ahead and go to the graph to visualize where the rest of the solution points are at. So let's see, we have -2, let me make sure, 1, 2, 3, 4. Right, so that's on my graph. We have -1, 1 that's on my graph. 0, 0 is on my graph. 1, 1 is on my graph. And 2, 4 is on my graph. All right, and so basically the pattern looks like what we famously call a parabola. And by the way, the last one was obviously a line. All right, and so there's basically a parabola. Don't forget your arrows, because this goes on forever. So the data point, if we were to let x equal to 3, right, 3 squared would take us all the way up here to 9 somewhere. So you can kind of, again, see every ordered pair that we see on this, the easy ones and even that crazy one, whatever the heck that data point is, if we can pinpoint it, right, it would make this equation true. So that is what a graph is. A graph is a visual representation of data, right? And in our case, since we're solving equations, it's a visual representation of all the solution points. Of course, we can't find them all. What we do is a little bit of point plotting, get a pattern, and then we can start to see all of the rest. And that's graphing 101 at its bare essence. So, of course, the graphing calculator will do this much faster. We'll see that for those who have never used it before. But hopefully those who have, you now know what you're actually looking at when you're looking at a graph. All right, we'll practice this a little bit more. I do want you guys to be able to graph by hand. So we'll do some more by hand in the next video.